All right, welcome back to Algebra 2. We are looking at 7.6 today, which is on solving exponential and log equations. Little warm-up to start us off with. You can pause it and do these questions, and I'm just going to go through them. All right, so the first one here, it says just to write this in exponential form. Write this equation in exponential form. So we have a log. Remember, a log or a logarithm is a function which takes in two things. It takes in a base, and it takes in this argument right here, this expression, this number, and it gives us an exponent. This right here is the exponent. So the way to rewrite this in exponential form, one of the tricks that I talked about before was to use the shark fin method, which is to say 3, this base, raised to the 4th is equal to that, right? So we can simply rewrite this equation as 3 raised to the 4th would have to equal 2x minus 7. That would be rewriting it in exponential form. Now notice too that this right here would allow us to easily solve for x. This is an equation we could solve for, and we know how to do just by adding and dividing. And so that's kind of a foreshadowing of what we're getting into today. Second question, it says write 8 raised to the x equals 30 in log form, in logarithmic form. So, all right. If we do that, that means we're going to have a log function which takes in two numbers, a base. The base in this problem is 8, so I'm going to put that as my base 8. And then we're going to have some number in here that's going to equal some exponent, right? Exponent. So what is this exponent? Well, if we look in our original equation, we can see that the only exponent that we have there is x. So that x would have to be on the right, right? That x would have to be on the right. And then the result of that, the 30, would have to be here. This is log form, meaning both of these equations that I just circled are equivalent. They're expressing the same relationship, but one is written with a log function involved, and one is not. Okay, next one says solve the equations. So it says 100 raised to some number equals 1,000. Okay, so we have to think about 100 raised to what number equals 1,000. So this is a example of something we're going to get into today. This is an exponential equation. We're trying to solve for an exponent here. There's several ways we could try to figure this out. One is through just kind of trial and error. We could just think about, what if we plugged in, just pick some numbers to plug in there for x. Just kind of guess and check. It's one way to do it. So if you kind of fiddled around with this, you would know that this number right here, x, x there, is going to be 3/2. So that's to say that 100 raised to the 3/2 is equal to 1,000. So you could have used trial and error there and just like plugged in numbers until you got 1,000. You could have thought about exponent properties and if I start with 100, what could I do to 100 to get to 1,000? So certainly we could multiply by 10, and that would give us that would get to 1,000. But if I have to think in terms of exponents, that doesn't quite work. So if I took the square root of 100, I know that that is 10. Right? I could think of it like that. And if I took 10 and then I raised it to the 3rd, that would give me to 1,000. So this is something that we could express with the exponents, because if I take the square root of something that's equivalent, we can express that with an exponent as 100 raised to the 1/2, right? If I take 100 raised to the 1/2, it's like a square root, and then if I raise that to the 3, that would get me to 1,000. Hence, that's how I could get 100 to the 3/2. It's another way you could think about it. But today we're really going to be thinking about how to solve this type of problem, and we can use actual logarithms to do that. All right. Second one, or the next one, solve log base 5 of x equals -3. So in order to solve this one, it would be easiest to just rewrite this in exponential form. So I'm going to use a shark fin here. 5 to the -3 is equal to x. I'm just going to rewrite that. 5 to the -3 is equal to x. And actually, just by rewriting it, we've solved it. X is equal to 5 to the -3. 5 to the -3, by the way, is equal to 1 over 5 to the +3, which is 1 over 125. Last one, we have a quadratic. X squared minus 7x minus 60 equals 0. That's a quadratic, so how do we solve that? The two possible tools we can use would be the maybe factor it, or we could use a quadratic formula. I'm going to go ahead and try to factor this. So my a value is 1. My a times c is -60. My b value is -7. So I'm trying to think about what multiplies up to -60 and adds up to -7. So think about 12 times 5. 12 times 5 is 60. It needs to multiply to -60, so I have to make one of those negative, and I'm going to choose 12 to be negative. So -12 times 5 is -60, and -12 plus 5 is -7. So therefore, I can factor this as x minus 12 and x plus 5. Once I have that factored, I could use a zero product property, and I can state that x is going to be equal to 12 or x is equal to -5. Some terminology that we'll use today as we get into this section 7.6. When we have equations where variable expressions are part of the exponent, that's going to be an exponential equation. So exponential equation. So if I had something like 5 raised to the, let's say, 2x equals whatever, 122. If I have an equation like this where the thing that I don't know, what I'm trying to find is the exponent or is part of the exponent, then that would be an exponential equation. And then equations that involve logarithms of variables or variable expressions would be log or logarithm, logarithmic equations. I'm just going to put here a log equation. So for example, if I have log base, I don't know, 5 of x, or I could say anything with a variable in it, so like 3x, and that equals 1,000. If what I'm trying to solve for or find is inside of a logarithm, inside of that log function, then that's a log equation that I'm trying to solve.